Well, hello everyone. This is Mr. Ihsan, and I shall be pleased to answer this question, which seems to be from a mechanics subject. Now, let me start with this question. We have a mass of P of 2 kilograms, and that is on a rough horizontal table. So rough horizontal table means we have friction, okay? And that it's tied to a light horizontal elastic string. Okay, so natural length is 2 meters and stiffness. Okay, so we have some elastic force there. And that string is also attached to Q, point Q on the table. And the mass is held such that we have the distance between the 2 points from P, which is the mass, and Q, which is the origin of the string, is 3 meters. And we need to find, that's the first requirement, to find the initial acceleration. Okay, so that's the first requirement, the initial acceleration. And what's the distance? And then that's the second requirement, to find distance PQ when the mass comes to rest. Good. And then we have another input of information that the friction is 3/5 of the normal reaction. Good. All right. So that's the mechanics problem. And basically we need to decode everything on a diagram to help us to analyze the forces and solve the question. So first of all, let's have our rough table, horizontal table. That's a rough horizontal table. And then we have a mass of P. So I'll just put it as a rectangular block. Mass P. And then, of course, that is 2 kilograms. And that's tied to an elastic string, okay, to point Q. Okay, now 2 things here I have to note: that the original length of the string is 2 meters, okay, and then this means that I have an extension here because it says PQ is 3 meters, so I have here an extension of 1 meter. All right, and so the first thing really is, let me just draw the balance of forces, the free body diagram that is acting on the body P. So here I have P. Now vertically, of course, I would have the weight, and vertically I would have also the reaction. So that's the reaction, and that's the weight. And of course, in the horizontal dimension, I have friction. I'll call that as F for friction. And on the other side, I would have, of course, the elastic force. I'll call that Fe, or F, elastic force from the string. Okay. Now, of course, I'd have initial acceleration because the forces are unbalanced. Now, first of all, let me find the frictional force, because I can find the W, which is basically mg, which is 2 kilograms times 9.8, or 9.81 if you must. So if we do that, let's just do the number crunching first. That is approximately, well, yeah, that's just basically 20. Okay, but accuracy there 10 times 10. So that's 19.62 newtons. Now, that is the vertical downward force from the weight. Now, of course, I know that there is no other motion in the vertical plane, so therefore the reaction must be equal to the weight. So that's also equal to 19.62 newtons. Right. Now, this is good because then looking horizontally, okay, I can find from that information the frictional force. Okay, so we have here the information that the frictional force is what? It is 3/5. So that's 3/5 of the reaction, which is 19.62. That's the frictional force. So frictional force is basically 0.6 of the reaction. And if I do that on my calculator, I get a value of 11.772. Now let us round up towards the end. Let's not start rounding up values now. So that is basically my frictional force acting on the body, on this mass. Now, the final step is finding my elastic force that's coming from the string. Now, we have K, which is given here, and we have also the extension, which is basically beyond the natural length, which is basically 1 meter. So Kx, this is the basically the formula, okay, which is basically 25 newtons per meter times 1 meter, which basically gives me 25 newtons. Good. So now I can then basically retranslate all this to a simple balance of forces problem, okay? So let me just summarize the values here, and then we will basically find the acceleration. So just to summarize here, I have here the frictional force to be equal to 11.772 newtons, and the elastic force to be equal to elastic force to be 25 newtons. Yeah. All right. Okay, great. Now, for the dynamic part of this problem, basically I have, again, this mass. Okay, and then I have a frictional force here, which is 11.772. And of course, at the front, I have 25 newtons, which is the elastic force. Okay, so my question here, what is the net force? What is the resultant force? Well, of course, I'm sure all of you would be happy to say that the simply it's the difference between them. It is the 25 minus 11.772. So let me put that F net, the net force, and of course towards the right is the larger one. So this is my net force. That's F net, that direction. So F net is simply 25 newtons minus 11.772. And if I do that on my calculator, okay, 25 minus 11.772, I get 13.228 newtons. This is my net force. Now, the dynamic equation for that is simply that the net force equals mass times acceleration, which is 13.228. Now, I have my mass, which is 2 kilograms. So I can easily now substitute 2 times A, which is my unknown. Now, of course, if I rearrange, I'm sure all of you have done your algebra. And therefore, if I divide by 2 both sides, I get acceleration to be approximately to 2SF. If you wish to do 3SF, as up to you, but 2SF, I get 6.6 meters per second squared. And of course, the direction is going from left to right like that, okay? And that's the answer for the first part. Good, okay. So all well for the first part. Now for the second part. Now, for the second part, it asks for the distance traveled when the frictional force is the frictional force is equal to the elastic force, or it is basically balanced, okay, at rest, using Newton's first law. If there's no net force acting on it. So let me make that statement, okay. Here I have my body. Of course, I use red just because it's a different situation than the earlier one, okay. Here I have my frictional force, which is the same, 11.772, hasn't changed because the reaction hasn't changed. This is the frictional force, okay? Now, here, I should have balance of forces because the keyword is to rest. Remember Newton's first law, everybody is at rest or a constant velocity unless a force acts upon it. So that force must be equal, okay? So 11.772 newtons. Okay. So now I'm going to go and work backwards. For that elastic force, what will be the extension on the spring? Okay, so that 11.772, which is my elastic force, should equal to Kx. Okay, extension is unknown. Okay, fine, fair enough. So now let me basically rework it. So I know K is 25. So that's 25x equals 11.772. If I reorder that, what is 11.772 divided by 25? I get extension equals to 2SF really, 0.478. Is it? No, 0.8. So I beg your pardon. 471 then. Okay, 471 meters. Now, hang on. Okay, even though that's the extension, that's not the distance traveled. Now, let me just sketch the whole thing again. Okay, I have here my flat rough surface. Okay, and I'm measuring the extension from Q. Okay, so here is my Q original length, which is 2 meters. Okay, and here is my body P. Okay, 2 is the L note or the original length. And now I have my extension here, which is 0.478. Okay, that's the extension. But hang on, my original starting point was 1 meter, right? Okay, so which was a point here for, say, P dash, the original one. Okay, so really the distance traveled from the original position to that one will be 1 minus 0.478. That's the distance traveled. I'll call that S. So now S is basically the original extension, which is 1 meter, minus the final extension, which is 471. Why I'm putting 8? 471. Okay, and if I do that, I get 0.529 meters. This is the distance traveled. Now, of course, you can just stick it into SF. 4 meters around. That's your answer for the second part. I hope that has been useful. And by all means, feel free to give me some feedback on this video, and I hope it has been helpful. Thank you very much, and bye-bye.